Once again, I am welcoming for the session number 5 pertaining to the hydrology and irrigation engineering for 7th semester students. So far in the 4 sessions we have discussed about the irrigation systems and design of canals. Definition used in water requirement of crops continued here. The cultivable command area the cultivable command area is the area of irrigation land which is actually cultivated or which is under the irrigation, brought under the irrigations. It consists of all areas which can be cultivated, which can be you are using the land for the growing the crops. That's called a cultivable. Cultivable means it is irrigable. Cultivable or IC, even you can call it as a IC also. Cultivable command area or IC, irrigable command area, one and the same. Out of the grass command area, some area is cultivable or which is under irrigations. That area you are going to call it as ICA or CCA, cultivable command area. In that area only you are using the use that area for the growing the crops. Reducing all or deducting all the areas which are uncommandable or unused for irrigations. For example, roads, buildings, parks, graveyards. So many things, right, which are not under the cultivable or which are not under the irrigable area. The left out area is cultivable command area. Usually in the for thumb rule or for example, you can use 80% of the grass command area can be cultivable command area or irrigable command area. Rough estimation is about 80% you can use for the cultivable command area. That is CCA is equal to GCA minus uncultivable area, which is uncultivable area means it may what we discussed is for example roads and other things which are uncultivable areas. CCA is further classified as cultivable cultivated area. It is an area in which crop is grown in particular time of crop season. Cultivable cultivated area. Actually you are growing the crop, but out of this CCA some area is left out. That is called as, and even though it is in the cultivable command area or ICA, that you are not growing the crops. For example, waterlogged areas or barren lands, the areas which you cannot supply the waters. Some area is left out. That area you can call it as uncultivable. Even though it is cultivable, considered a cultivable area, you are actually not growing the crops there. Okay. Cultivable, uncultivable area. It is an area in which crops is not grown in particular region. Such area is kept under no cultivations due to the following reasons. The following reasons may be to increase the fertility of the land. For rotation of the crops, you might have heard the word rotation of the crops. For rotation of the crops, some area is left for not growing the crops. Is it not? You are not using the water for that area. Is it not? The reason is that which has reduced due to increase in cultivation. But you are going to increase the cultivation, that is fertility of the land, by keeping the land open to the sunshine and other things. The land must be left for growing grass for animals. Even though you are not growing the crops for men and women things, but the things you are using the area for the growing the grass and commercial things. To protect from waterlogging is what we discussed. Protect from the waterlogging. Some of the area is lost due to waterlogging. That you are not going to use for the irrigations. That is under uncultivable area. Next definition, important definition, intensity of irrigation. Intensity of irrigation is defined as percentage of CCA, that means cultivable command area, which is proposed to be annually irrigated which is annually irrigated is the intensity of irrigations. That means intensity of irrigation is equal to area to be irrigated divided by 100. That means percentage of intensity of irrigation into 100. That is called as intensity of irrigation. Consumptive use of water. Consumptive, very important definition. Consumptive use of water. Actually the water required for the healthy growth of the plant, as well as the yielding the things, and also the water consumed by the plants for not only for evaporation, also for transpiration. That's why it is called as evapotranspiration. Evapotranspiration and consumptive use are one and the same. Evapotranspiration means water consumed for evaporation as well as transpiration. Transpiration means breathing or growing the crops. The water required to meet the evapotranspiration. Evaporation means water evaporated from the leaves of the plants or directly from the soil. Is it not? Whatever amount. So for example, 100 liters of water you are going to supply for the field. 100 liters of water cannot be used for the plants. Some of the water will be evaporated back to the atmosphere from the roots itself, from the soil itself, from the leaves. For example, if you are using the sprinkler system of irrigations, in that case, the drops of water are accumulated on the leaves. It is not used for the. It will not used for the plants for its growth, or it will not absorbed by the roots of the plants. Directly it will go to the atmosphere or evaporated back to the atmosphere. That is called as evaporations. The amount which is actually absorbed by the plants, the roots, that is called as transpiration. So what? The total of the evaporation plus transpiration will be called as evapotranspiration. That quantity of water is consumptive use of the water. That is used nothing but consumptive use of water. Okay. Next one, next definition. Cash crops. Cash crops, the crops which are used for the growing the cash. That means cash crops means, for example, vegetables, cotton, which are not actually consumed by the persons for its food. For example, food grain items are not cash crops. The crops which fetches the farmers to the cash. For example, marketing. Is it not? So it may be vegetables. It may be in cotton, it may be sugar cane, all are cash crops. You can see, is it not? So the farmers, some of the farmers are using the crops for their economical improvements. That's why whatever the crops grown by the plants cannot be consumed by the persons, or it will not be a food grain items. Is it not? For the farmers to be in the marketing place, or they have to grow the cash crop also to improve the economic status of the farmer. That's why mixed cropping system. The farmer has to grow the food grains as well as the cash crops. For example, sericulture, sugar cane, right? So they are all the cash crops. The leaves eatable by these sericulture, is it not? Worms, is it not? They are all cash crops. Crops like vegetable are cultivated by farmers to sell in market to meet current financial requirements are called cash crops. Right? Time factor. The ratio of number of days the canal is actually running to number of days of the irrigated period is called as time factor. How many days the canal is actually running is called the time factor. For example, 120 days are required. Out of 120 days, actually the canal may run for 90 days or 80 days. That's called as time factor. Delta, very important definition. Delta, if each crop requires certain quantity of water at regular intervals of time throughout the cross period. Delta is nothing but the total depth of water required from the sowing to the harvesting. That is, for example, in the first watering itself, you are leaving this water at a 2 centimeter depth. After that, next watering, second watering, 3 centimeter, 4 centimeter, like that. All together, total depth is, for example, 40 centimeter, may be the total depth of water on the area. Yes. Capacity factor. Definition defined as average discharge required by crop from canal to a maximum discharge of the canal. Capacity factor. How much capacity? For example, actually how much the canal is running, how much actually the top level of the canal. Capacity factor. What is the capacity of the canal? Whether it is running full, whether it is running in the out of a freeboard, FSL level, they are all the capacity factors. Frequency. Frequency of irrigation. Frequency of irrigation is number of watering applied to crop throughout the base period. Frequencies, the number of the waterings is called as the frequency of irrigation. How many frequencies of irrigation? For 9 days, 9 days, 9 days, or 6 days, 7 days, depending upon the type of the crop, depending upon these climatic conditions, the frequency changes. Crop season, the period during which some particular types of crops can be grown every year on same land is known as crop season. The period during which some particular types of crops can be grown every year in the same land is known as crop seasons. Crops can be classified as the following basis: based on the cultural area, based on crop season, based on irrigation requirement, the crops can be classified. Right? Based on agriculture, based on crop season, based on irrigation requirements. Based on agriculture, the crops can be classified as based on agriculture: field crops, wheat, rice, maize, barley, etc. Commercial crops, sugarcane, cotton, tobacco, etc. Oilseed crops, groundnut, mustard, castor oil, etc. Horticulture crops, fruit crops, vegetable crops, flower crops, they are all horticulture crops. Plantation crops may be coffee, tea, coconut, rubber, etc. and etc. Forage crops, fodder crops, grass, right, for the which is feeding to the animals, grass, fodder, etc. Miscellaneous crops, spice crops, medical crops, that is, they are all the different crops, that means miscellaneous crops. Depending upon the agriculture, the crops are classified like this. Second one, based on the crop season. Based on the crop season. In India, based on the crop season, there are two seasons are there. The crops are divided into two seasons: Rabi or winter crops. These crops are sown in beginning of the winter and are harvested in spring season. Is characterized by bright sunshine, absence of the cloudy days, lower humidity. These are all called the winter crops or Rabi crops. Similarly, the crops under Rabi are classified as examples of the Rabi crops are wheat, barley, peas, mustard, tobacco, onion, etc. and etc. Next one, second one is Kharif crops. Kharif, or it can also be called as monsoon crops, winter crops and monsoon crops, or Rabi crops or Kharif crops. These crops sown in every beginning of the monsoon and harvested at the end of the autumn. Season is characterized by gradual falling temperature, the large number of rainy days, low light intensity, high humidity, climatic weather. In these climatic weathers, Kharif crops are grown. Examples of the Kharif crops are rice, maize, groundnut, etc. and etc. Altogether, once again, the crops grown during Kharif as well as Rabi seasons are perennial crops or biseasonal crops. The crops are crops that requires water throughout the year. Perennial crops. Perennial crops means you are going to supply the water throughout the year. That is called as perennial crops, right? Examples of the perennial crops are sugarcane, fruits, vegetables. You can grow the vegetable throughout the year. You have to supply the water throughout the year for the sugarcane. So that's why these crops are called as perennial crops, right? The last one is 8-month crops also, which requires water for 8 months based on irrigation requirement. The last classification of crops are based on irrigation requirement, right? Based on irrigation requirement, the crops are dry crops, do not need water for irrigation, rainwater is sufficient for this, right? So wet crops cannot grow without irrigation, they are all also that irrigation. Good garden crops requires irrigation throughout the year. This based on this, the crops are also classified. Yes. Seasons of India. Crop seasons in India are, look at this table: Kharif season, Rabi season, perennial crops, right? Once again, the Kharif crops are rice, maize, bajra, jawar, pulses, groundnut, etc. and etc. Sowing time is almost June to July, except the groundnut may be grown at May, right? The harvesting time for all the Kharif season is usually October to November, September to October. That, for example, bajra is September to October, jawar is October to November, pulses is November to December, groundnut is September. The average delta, the average delta for this particular crops are rice for 120 days to 120 centimeters, maize 45 centimeters, bajra 30 centimeters, jawar is also 30 centimeter, pulse 30 centimeter, groundnut 45 centimeter. That means total 40 centimeter of the depth of water is required on the field. Similarly, Rabi crops are also gram, wheat, barley, peas, mustard, tobacco and potato. Accordingly, the growing season is given, and also harvest season is also given. The average delta of these crops are also given, that is 30 centimeter, 40 centimeter, 45 centimeter, 50 centimeter, 45, so and so forth. Right? Perennial crops are usually the sugarcane, that is February to March. Harvesting is December to March. That average delta for this sugarcane is 90 centimeters. Okay. Water requirement of the crops once again continue. It is defined as quantity of water required by a crop in a given period of time for normal growth under field condition. It includes evaporations and other unavailable water also. It may be expressed as seasonal, consumptive use or unavailable percolation, right? Yes. Expressed as water depth to unit area. Numerically, water requirement is equal to A plus B plus C, where A is equal to consumptive use or evapotranspiration, B is equal to application and conveyance losses, and third one is other special needs. That means the water requirement of the particular crop is evapotranspiration or consumptive use plus the conveyance losses. Conveyance losses means maybe losses due to seepage in the canal, losses due to evaporation in the canal, that is illegal watering tapping by the farmers. All these are all the application or conveyance losses, right? And other special needs. Other special needs means for extra irrigation seasons you have to supply the excess water, right? Unit water requirement. It is defined as weight of water actually used by the plant in providing unit weight of dry matter, right? Next very important thing is duty of water. Duty definition. It is relationship between volume of water and area of the crop brought under maturity. It is relation between volume of water and area of crop brought under maturity. Or once again, duty is also defined as duty of water is defined as number of hectares brought to maturity by constant supply of water throughout the base period, expressed as hectare per cubic. It is also expressed in terms of depth of water represented by D. Yes, duty is defined as D is equal to A by Q. A by Q, area brought under cultivation for 1 cubic of discharge. 1 cumex of discharge, how much area you are going to use or how much area you are going to brought under irrigation is called as duty of irrigation water. Duty of irrigation water, right? Importance of duty. It helps in designing an efficient irrigation canal system. If you know the duty, definitely you can that factor is used for the designing system of the canals. Canals may be field canals, laterals, distributaries, sub-distributaries and main canals, so and so forth. Irrigation system is based on the designing of irrigation system is based on the duty of irrigation water. It is to be irrigated can be easily calculated. Area is to be irrigated can be calculated. It helps in calculating discharge for design of channels. It helps in checking of efficiency of canal system. Next, definition of this duty is very important. You have heard that. You know that, is it not? D is equal to A by Q. That means A is equal to area, D is equal to discharge. For 1 cumex of the discharge, how much area is brought under irrigation is nothing but defined as a duty, that is hectare by cumex. Right. Factors affecting duty. What are the factors actually who are affecting the duty of the irrigation water? Types of the crops. Different types of the crops requires varying variety of the varies from crop to crop. The duty of the irrigation water is varies from crop to crop. For example, sugar cane and maize and pulse, so and forth. Duty of sugar cane is less, whereas the duty of the maize is more. That means sugar cane requires more water, pulses or maize requires less water. That's called duty is more. And if the discharge is less, naturally area is more. B is equal to A by Q. If the denominator is less, numerator will be more. That means for lesser discharge, more area irrigation. Is it not? That's the thing. Crops which requires large quantity of water have lower duty of water than crops which requires less quantity of water, obviously. Climatic conditions of area, climatic conditions like temperature, wind velocity, rainfall, humidity will affect the duty of water. More evaporations in high temperature and less, and vice versa. Is it not? Climatic conditions also plays a very important role in the duty. If the climate is hot, more and more water you have to supply, duty will be reduced. Right? If the temperature humidity, less water is supplied to the plant, so the duty will be more. Useful rainfall is also there, wind velocity is also there, wind direction is also important. All are playing very important role in the duties. System of irrigation, whether you are going to use the system of irrigation means whether you are going to use the sprinkler system, subsurface system or flow system, direct flooding system. Is it not? Flooding system is less duty, and sprinkler and subsurface irrigations are more duty because they are supplying the water directly to the root zone. Is it not? Other conveyance losses are less, right? Evaporation losses are reduced because you are supplying the water through the piping system. That's why conveyance losses seepage losses are also reduced. So that's why duty is more. For perennial irrigation system, duty of water is high. For inundation irrigation system, duty of water is low. Method of irrigation also plays an important role. Is it not? Which method you are going to apply, whether flow irrigations, ditch irrigation, zigzag method irrigation, so and so methods are playing an important role in calculation of the duty or assigning the duty. Duty of water is higher for furrow method of irrigation than surface irrigation methods. If furrow method is used, directly you are supplying the water to the root zone, so that's why more and more water used by the consumed by the plants, right? So duty is more. If the flooding is there, direct flooding is there, you are more and more water has to be supplied to the plant in order to spread the entire area. So out of that entire area, some of the water may be lost. That's why irrigation the duty is less. For drip irrigation, duty of water is high. Naturally, quantity of irrigation water, quantity of irrigation water as well as quality of irrigation water also plays an important role in the duty. If the water contains high harmful salts and alkalines, lower duty of water due to more wastage, right? Quality of water is also a very important role. Best quality of water results in high duty of water, right? Time of irrigation and frequency of irrigation also play an important role. Depending upon this frequency also, the irrigation duty of irrigation water changes. In initial stage, land requires more water, hence lower duty of water is there. Continuous irrigation and cultivation increases water table, resulting in higher duty of water. Frequent irrigation reduces less loss of moisture, increases duty of water. Types of soil is soil in the field. Coarse grained soil reduces duty of water because more and more water will be percolates. Presence of impervious layer below root zone increase duty of water because it holds the water for the root zone and the duty of the water increases. Type of the soil in canals. If the canal is unlined, duty of water is low. The canal is lined, duty of water is more because there will not be seepage. There will not be a seepage in the lined canal rather than the unlined canal. If cultivator is unskilled, more wastage of water and thus lower duty of water. Is it not? Unskilled person is irrigating that because of unkilledness, because of lack in the technology, lack in the awareness of this irrigation system, the duty will be less. Topography of the land is also plays important. If the topography is steep slopes, the more and water has to be that is seepage out. That's called as duty of the water. Leveled land irrigation results in higher duty rather than the steep land. Unleveled land results in lower duty of water based on the crops also. Is it not? Yes. If the base period of the crop is long, lower duty of water. If less, leads to higher duty. Is it not what we are discussing? For example, base period of the sugarcane is more, duty is less. Base period of the maize is less, duty will be higher. Is it not? Method of improving, yes. Next, these are the factors affecting the duty. Next one is methods of improvement of the duty. How we are going to improve the duty so that with the less water, maximum crops can be grown or maximum yield can be taken from the crops. Is it not? That is the method of improvement of the duty. If you improve the duty of the water, naturally you will get the more yield. Is it not? Less water, more yield. Or less water, more area will be brought under cultivation, brought under ICA. That's how we are going to improve the methods of improvement of the duty. Suitable method of irrigation should be used. Cultivators must be encouraged to adopt modern method of cultivations and should be trained. Is it not? Cultivators should be encouraged to adopt modern method of cultivation as well as they should be trained. Canal length should be minimized. Very important. Canal length should be minimized means unnecessary, that ideal length of the canal should be reduced. So that means the storage of the water and the irrigation field should be closer to each other. That means you may be reducing the conveyance losses as well as the evaporation losses. That's the idea. Canal should be nearer to the land to be irrigated. Canal should be lined, which reduces the seepage losses. The canal should be properly maintained to reduce the losses of water. That means the foresting of the canal all along the canal should be reduced. Volumetric assessment of water should be made. Very important. Volumetric assessment of the water is very important because you have to, volumetric means on volume basis, or how much of the liters or how much of the cubic feet of water, how much of this meter cube of water you are going to supply is the volumetric method. Unnecessarily you should not leave the water on the discharge basis. So for example, for how much of the volume of water is required for the particular crop should be based on the volumetric assessment. Then it will be use the improvement in the duty. Good quality of water should be used for irrigation to avoid canal or polluting. Land should be properly prepared to require depth and level before the sowing. Is it not? Method of cultivation is very important. The proper method of cultivation is in higher duty of water. The method of assessment of irrigation water is important also. Assessment of water on a volumetric base prevents wastage of water and higher duty of water. Assessment on flat rate basis reduces the duty. What we are practicing nowadays was flat rate. Flat rate means for a particular crop, this much of water is required. Is it not? We are not practicing the volumetric basis. That is called as That is flat rate basis, is it not? That gives the unscientific method, which gives unnecessary the wastage of the water, which reduces the duty. Skill of cultivation is also important. The land should be frequently cultivated, which reduces the loss of moisture from the soil, is it not? The increasing water holding capacity of the soils through the suitable methods of cultivation. The rotation of crops should be adopted to increase moisture retaining capacity and fertility of the soil. So rotation of the crops is a very important factors to improve the duty, where which should not grow the continuously the same crop for the consecutive 4 years, 5 years like that. Is it not? You have to change the crops so that the moisture holding capacity of the soil increases, and duty as well as the fertility of the land increases, and also the yield will be increases. The duty of the water will be increases. Sprinkler methods, drip method, and modern techniques of irrigation should be adopted to improve the duty. So this is the what we have discussed is improvement of the duties. So this is the end of the session. In the particular section, in the next subsequent sections, the calculation of the delta, crop period, so and so forth, that will be designing of the canal systems. We will continue in the next session. Thank you. Thank you, friends. Thank you. Right. Thank you, friends. Thank you.